Hey, and welcome to MCR Bot Builds for new builders. In this episode, we'll be looking at wiring for your combat robot. Wiring up your robot is basically the same whether it's an Antweight, a Beetleweight like this one, or a Featherweight. There's obviously some differences, and a Heavyweight obviously has major differences. But for this level class, there's some all basically use the same sort of pieces. So I'll just pull out the battery here and look at this mess of wiring. But underneath this mess, what I wanted to show you is a particular way of actually putting these together without too much trouble. And that is what I'm looking at now. It's these black lumps. So what I'm doing there is this is where we get the common ground and the common power. Now, while there are different ways of joining these together, whether it's solder or screw caps or terminal strips, in this case, I'm actually using a bolt in each of these. And a bolt means that I don't need to solder, I don't need to deal with screw bolts, and it just makes it a lot simpler to actually put together. And especially simple if it breaks down during a combat. All I have to do is undo these bolts, which side it is, and replace it. And then I'll put some tape around it and put this mess back into the Beetle, and off I go again. All I use are some I-terminals or eyelet terminals that can fit an M3 bolt, and you can get these in any electrical store. So all I do is take off some of the insulation with a pair of pliers. There I am left with the eyelet ready to go. As you can see, it's quite small, fits an M3 bolts, and what I do with those is put those at the end of anything that requires power, whether that's ground or the power cord itself. This is the full set of parts that we'll be using today, and to make it a little bit easier, I've included this parts list that shows you at least what I'm using. Doesn't mean this is the correct set, but we'll have more details in the links below for this set. As you can see, there's quite a few parts, a lot in packages, so let's get on with the wiring. This is the wiring diagram that we're going to be using today for this Beetle, and as you can see, there's quite a number of connections, and it looks, for those that haven't done this before, quite complex. But to make it a little easier, what we should do is break these down in parts. So we'll do each section one at a time. So the first one we're going to do is the drive ESCs. And all we need to do here is attach the two I-terminals. As I'm using brushed motors, I'll be using the BotBits 10 amps brushed ESCs. As you can see, I have the eyelets sitting there waiting. And now I just need to collect up some parts. So I'll be using some heat shrink. And I'll need to solder some of these on. So the first thing I'll probably need to do is take a bit of the covering off. And don't forget to put the heat shrink on. Nothing worse than putting the connectors on and only realizing you left the heat shrink off. And all I need to do here is just crimp those on. Okay, so I'll put those in. It's all connected and ready to go. And put the second one in. Same deal. Stick it in the gripper first. Put the wire in and crimp. Not particularly difficult. So the next things I'll do here, and this is up to you, in combat robots there is a lot of force involved, especially in a hit. So just to give them a little bit extra strength, I put a little bit of solder in just to make sure that they can't be pulled back through. A little bit of a dob in the first, just get it hot. Let a little bit of solder go in until it starts bubbling inside, just enough to hold it there. put into the second, same deal, just enough, just to get inside, mix up with the connector and the wire, bubble it, and you're done. We now have 2 connectors done. What we need to do now is finish the job, pull the heat shrink down, put it in the right position so it just leaves the eyelet there, enough room so that other eyelets can jam in on top, and use our heat gun. Now you don't have to use a heat gun if you haven't got one. A soldering iron can do the job as much as anything, or if you just want to use electrical tape. And there we have it, 1 ESC complete. Now I'll do the second one off camera, but basically it's a total repeat of the first. And now we move on to the weapon ESC. This ESC is a multi-star 41 amp brushless from Hobby King. And of course we're using a brushless weapon motor in this case, but the connections that we need to do with the eyelets are exactly the same as what we did for the driver ESCs. This is our weapon ESC for our weapon motor, which is a brushless motor. And what we need to do is put those same eyelets that we just did for our driver ESCs onto this ESC. So basically just the same place. Once again, we strip down the wires just to take a little bit off, get enough purchase so when we push it through the eyelets there's enough there to actually crimp to. We'll put on some heat shrink and actually remember to put it on before putting the eyelets on. Okay, and now we're ready to go to crimp it. So put the eyelet into the crimper, get it lined up, push the wire in to make sure it's actually on, and crimp. And it probably takes a couple of little crimps just to make sure it's in place. Same thing again, line it up, push the red wire in, make sure it's all lined up, and crimp, and a couple of little crimps there. And that's really all there is to it. So we'll put the heat shrink back up, line it up to just the right spot, giving enough clearance so that other eyelets will jam up next to it when we put them on the bolt. I'm again using the heat gun, but you could use your soldering iron, or instead of heat shrink just use electrical tape. And that's all there is to it as far as the connections go. Since this is a brushless ESC, connected to most likely a brushless motor for a weapon, it's also the most likely piece that may give you problems during an event. It may be hit, so what we're going to do is obviously connect these to the ESC, but the way I'd like to do it is a way where you can actually easily connect it and disconnect it from the ESC if you need to swap it over. So the way I'm going to do that is by using these off-the-shelf bullet connectors, female bullet connectors, which fit into the motor. And what I'll do is actually put those bullet connectors and attach them onto the ESC itself. Now I don't need the rest of these pieces anymore, so I can get rid of those. But I will need 3. Now these connectors don't actually fit quite well on this, and there's several different ways of doing it, but these just happen to be the right size where if I get a pair of pliers, I can actually squash the end down, the connecting end down just a tad, and just with the right amount, which creates a bit of an oval shape, allows it to slide on to the connector, the solder pad. It just sort of fits on quite nicely. So I'm going to go ahead and do this. Now, that doesn't mean you always need to do it this way. You can certainly just solder directly onto these pads. You could still use these same bullet connectors and put a short length on between the pads and the connector and do it that way. Or you could use a terminal block. There's about a dozen different ways that you could actually do this. So I'm going to go ahead and do the same to the rest of these connectors and slide that on. And now I have 3. Now these are hardly going to stay there by themselves. As you can see, they'll fit in the machine quite well. So to make sure they do stay, and since there are soldering pads underneath it, what I'll do is add solder to these. These particular connectors have little holes, which you may not be able to see in this picture, but there's a little hole there which you can actually put solder through and then put some solder back and behind. So just to make sure there's definitely solder going through to the pad, and there's definitely solder actually inside the connector itself, just to make sure that these don't move. I'll just keep adding solder until I'm happy. As I said, put some behind and make sure it's going through. You can sort of see it bubbling through it as well. So we're putting some behind just to make sure that they all stick correctly. I'm going to keep playing with this until I'm happy with it, because the last thing I want to do is pull out a motor cable and have that come out with it. So that does that. Now I don't really want to leave them just like that, although they fit in the motor quite nicely, but as you can see, it wouldn't take much to short those between the motors. So what I need to do now is put some heat shrink around those, leaving the actual end of the connector, the bullet connector itself, so it's open to put the motor in, but just enough to cover it. Now, if you don't have heat shrink, you could certainly do this with electrical tape. Heat shrink's just a very easy way of doing it. So just cut the heat shrink roughly to length, and we can always trim it when we put it on. And that's certainly too long, so I'll have to trim that. So we just cut a little bit off. And there you go, it sits back quite nicely. Second one on, well, it's as long as the first, so that's going to be too long, so I'll have to chop that back too. It sits back nicely. And the third one. A little bit of a trim, bit of a clean up, and done. Heat shrink, of course. Let's shrink it. Now, as I said, you don't have to do it this way. This is a way that just happens to be the right size for these connectors. But you could use, like I said, other forms, whether you just solder it directly on, or even just a short length of cable, which I've used before, and that works quite well too. And there you have it, all connected in. That's come up quite well, and that's all we need to do for the weapon ESC. Now let's move along to the switch. We're going to be using a Fingertech mini power switch for this one. Most Beetles use these. They run by a twist of an Allen key, and you can use them in Antweights as well. Before we start wiring the switch, we need to know a few things first. So let's have a look at this existing Beetleweight. Now in this case, the switch is mounted on the side of the tower here. What we need to know is how long some of these cables need to be. And the first thing is how it fits in with the battery. So you can sort of see the battery wiring here at the moment, and we connect the power from the battery through to the switch. And then from there, on the other side, it goes to this mess of tape. And under the tape, we've got our bolt with our little connectors like this one, our little eyelets. So what we need to know is the distance that we need to then get a bit of understanding. It doesn't have to be exact, but a bit of an understanding, because these wires are A, quite heavy, and B, quite stiff. Now this one's from another one that I built and it's out by itself. And you can sort of see where we want to lean to. It's not particularly difficult. We're just going to get the power through to the switch and then just have it in the distance in such a way that we know where the ground is going to be and where the power is going to be, and we have the correct distances for that. Looking at the diagram, we can sort of see exactly the same thing, but as you can see, it's very straightforward. Weirdly though, as straightforward as it is, this bit takes me longer than any other part put together, but there really is not much to it. I want to try and mimic this one that I made earlier. So I'm going to use this connector. Now that connector with the XT60, I'm actually cheating a little bit. That comes from Hobby King, and it comes as a set. It just saves me soldering those. I'm going to use 2 eyelets, which I'll be connecting to the end just like this one, and just exactly the same as we've done before. Now in this case, I need to cut these back a little bit. So just taking a basic measurement from these. I'll cut that off. And with the red wire, it's going to come around to the switch, and I'm going to take it just a little bit off. And now I'll just strip back a little bit. It's quite thick, this wire. It's a 12 gauge. It needs to be that thick because you have ending up to 50 amps going through for short periods of time. Okay, so and for the rest of this, I'm speeding this up a bit because generally we've done basically most of this before. So we still have the crimps, just like we did before. A little bit tighter this time because it is thicker gauge wire, but the idea is exactly the same. And we crimp that on. And what I haven't discovered yet is that I have actually forgotten to put the heat shrink on. So yeah, I'll solder this in. So this, again, just like before, putting some solder in just to make sure that it doesn't actually get pulled apart. Now being crimped, it really shouldn't, but this just makes sure that it never will. And I'll put some tape around since I don't have any heat shrink, but it does the same job. Right, moving on to the switch. Now in this case, I want to put this to one side of the switch. So what happens in this switch is basically it uses an Allen key, and you screw that Allen key and actually it will join a plate between those two connectors. So it works exactly the same as any other switch, it's a much more robust switch than your normal switch, flicking type switch I suppose, or toggle switch. And I'm just tinning these before I put it on. I'm putting, these are quite thick wire, so I'll be putting a fair bit of solder on, but just tinning them. So they are quite robust. As I said, they can actually deal with quite a high current, especially for the periods of time that we use them with, which is a lot more than normal, a switch of this size. So now I'm just tinning the actual switch itself. And I've actually remembered to put the heat shrink on this time. And using the hands, soldering hands, get those all lined up, and once they're lined up, I'll then just solder those two together. And there you have it. Okay, that should be right now. We'll swap this over. And obviously we need the other side this. Now this one, because we haven't got any of it, we just take a length of the same gauge wire. As it says, 12 gauge. Get to the right length. I'm going to tin this end. And tin the other side of the switch. Get my hands lined up again. And basically just join those together. And there you have it. Take another piece of heat shrink. Both bits heat shrink and now just gets heat gun. And that looks looking good. Now we've got to put the other connector on, the other eyelet or eye terminal. Just neatening up a bit. Once again, forgetting to put the heat shrink on. Push that through, grip it on. It's looking good. And just as we did before, we're putting a little bit of solder in just to make sure it doesn't pull out. Again, very unlikely, but this just makes sure that just doesn't happen. So you just got to drop a little bit in and just wait till it almost bubbles. You can sort of see when it's actually dropping into the wire itself, and that's not coming out. Now there's a realization that I didn't have any heat shrink this time, so I will take some red tape and achieve the same goal. And there you have it. It's as easy as that. And that should look very similar. That's ready to go. And now for the fun bit. I get to bolt them all together. In this case I'm using M3 bolts, but it really comes down to size and shape of your eyelets. Here are all our parts that we've been working on and a couple extra bolts. So with a washer, I'll put a bolt through the power eyelet, and now I'll put it in an order of the likelihood of it coming off. So in a battle, the most likely part to be near replacing would be the weapon ESC, as it has the most likelihood of having spikes. So I'll put that on last, as you can see here. And then I'll put another washer and a nut on it. And by putting it on last, it just means that if I'm in the middle of battle or between events, I just need to pull the tape off. I need to take off the nut, and then I only need to worry about that top one rather than have to pull a whole lot of them apart. But which is really not that difficult anyway, but it just speeds up just that little bit. So what I'm doing here is just tightening it all together, because as you see as you put the eyelets together, they will need to be almost squashed together by the act of screwing it in. So what I'm doing here is just tightening up further and further. And as you can see, it looks pretty good. So now I'll do the exact same thing with the power side. The other one was the ground. Now there's the power side with the bolts and a washer through the eyelet from the power. Same thing again. I'll put on the ESCs that are least likely need replacing, which would be the drives. So I'll put those on first, and then I'll lastly put on the weapon motor ESC. If I can find it. And there it is. So all I need to do now is put another washer and a nut. Just need to tighten that nut. Now you can actually use copper bolts through here. You don't have to use your standard ones, but each of those eyelets, once they're jammed down on top of each other, actually conduct quite well. The bolt actually is having very little impact other than holding it all together. But if you really want to do a great job, you could actually put copper bolts in there. But as you can see, that's come up quite well. Quite sturdy, easy to replace. So all we need to do now is really just cover these to make sure that they don't short out. And we do that with electrical tape. So we just have to wrap these up just to make sure that everything is covered there, including the tip of the bolt itself. Don't have to go too crazy on this, although you don't want anything exposed. The good thing about electrical tape, it actually comes off quite easily. I certainly wouldn't be using Gorilla Tape or gaffer tape. That stuff just will never come off. So just stick with something simple like electrical tape. It will come off quite easily, and it comes in the nice colours here, black and red, so at least you know exactly what you're dealing with. So as before, we wrap these around the eyelets and the bolts just to make sure that everything is covered, especially the tip of the bolt. Again, not going too crazy, and cut that off. Just sort of squeeze it in there a bit, and that would be it as far as the eyelets and the power is concerned. That's all we need to do. So now we're going to start putting it all together. So what we're missing at the moment is some motors. Now these are the brushed Servo City Premium Planetary motors. So what we need to do to these is put the other end of the ESC onto them. So all I'm doing here, you don't really need to do this. This is just for later when we're videoing this, is that when I turn these, you can actually see them turning, and they'll have a little red flag turning around. So I'll put that on both of these motors. And there's my second little flag. So all we have to do now is solder the remaining wires of the brushed ESCs to the brushed motors. Now the thing about these wires is if you put them in one orientation, the motor will go in one direction, and if you solder them in the opposite way, there's only two little lugs on each motor, then the motor will turn in the opposite direction. So it's a one way of actually controlling the direction of which way is going forward and back. But you can actually do it through a transmitter. Now, what we're going to do is do both of these motors. But before we do that, while I remember it, is to be careful with the power. So these three remaining wires are what you plug into your receiver. So because we have power on both of these, and the receiver only requires, well, we only really want one, because it actually can introduce some voltage issues if you start trying to put multiple power sources on. So we want to cut one of these, and more to the point, only have one remaining power to your receiver. So when you plug these in, the power comes with it. So each of these have got a power wire. We only want one, so cut the other one off, and that's what I'm doing here. I'm actually cutting one of those red wires off the drives and just taping it back. Now I've still got ground and I still have the signal, so everything's going to work fine, and the receiver will be happy. It's got its power coming from the other connection, equivalent connection here, so it's not missing power. So I'm just taping those back just to make sure there's no possibility of anything touching where I've cut it, and that's ready to go. Now I can go back to what I should be doing, which is soldering these ESCs to the motors. So first thing to do, there's 2 tabs on these motors, so I'll tin both of those tabs on both of the motors. Just a bit of a blob of solder on both of them, just to make it really easy to connect these. Take the first 2, and stick that on. Take the second one. And like I said, if you go and reverse these, the motor will change the opposite direction. But you may not need to do it through your wiring if your transmitter actually has the ability to do this. Some ESCs also have the ability actually to swap these as well. And that's pretty straightforward. Both of those motors are now hooked up to their respective drive ESCs. Let's put a few things away. Lost my little flag there. I'll have to put that back on the motor. Ready to go. Okay, so those are there for the receiver. Now I have a motor, and I can easily plug this in. Now to reverse the motor, again you can do this through your transmitter, but just reversing 2 out of any of those 3 black wires will actually reverse the motor if you need to. But like I said, there's other ways you can actually reverse it through your ESC in some ESC cases, or you can actually do that by your transmitter. Now we use those 3 receiver plugs and we plug that into our receiver, and as it's shown there, you only want 1 power. Now some ESCs don't have power in it, so that's no problem, but in this case we'd cut 2 of those 3. And this is the receiver I'm using, and it's a orange RX from Hobby King, and it's just because that happens to suit the transmitter that I have. So make sure that whatever receiver you get matches up with your transmitter, and we do have a video dedicated to this, so check that out. So this is a 4-channel receiver, so I'm going to plug these in. So the weapon motor will go in on the throw, and you'll actually see THO or THRO written there. The drive motors will go on the aileron and the elevator. You may have to play around those which way these go. That's a typical sort of scenario for mode 2 transmitter, that is. And as you know, one of those has power to power the receiver. And we'll put a binding plug on, ready to go. And all that is almost ready to go. Just need to put a battery on. Now this is a 3S system. There's another video on batteries and chargers, so make sure you check that out. This is a 3S system. And I have my little Allen key here. Because I've got the binding thing in, when I turn this on, that should flash saying ready to bind. I'm just doing a last check to make sure, I'm doing a visual check to make sure it's not going to smoke. And there you go. It's all flashing quite nicely. Nothing's gone up in flames, which is always a plus. So this time, I'm going to do the same thing, but I'm actually going to bind it to this transmitter. So I'm all ready to go, just as I was before. The binding plug is still in there. I've got the transmitter switched off. I turn this on, it's now flashing. I turn and hold the bind key down on the transmitter, and that's now binding. that's now bound. So, if I move, as you can see there, I'm moving both of those motors quite happily. And if I hold this motor carefully, I can spin it, which it does. So that works perfectly. And there you have it. I'll just switch the system off. And last thing, pull out the bind key. Ready to go next time. So that's all we have for this episode. Don't forget that all the details of the options are documented below. Please check out our other episodes, including an introduction to drive motors. Thank you for watching, and see you in the arena.